computer and let me start sharing because I want to close this. Where am I? Here we go. Let's start sharing. Okay, so this is my browser. Before I do anything, let me click here. I want to go to the browser because I want to see what we're supposed to do today. And this is, let me see, where are we? November 7th. So here we go. This is our week. Now, in this week, as you can see here, we were supposed to have test 2. Because we're getting really, really close to the final and we don't have that much of classes available, I was thinking about having only two tests, test number 1 and the final exam. So we'll consider test number 1 as a midterm exam, and the test number 3 will be the final exam. And instead of dedicating this whole week for test number 2, we'll just continue normally with the rest of the chapters. I hope you guys are okay with that. And let me just make sure that the chat is open. And if you guys are okay, when you feel like you want to tell me that's okay, make sure you go and type something on. Sounds good. Okay. So today we are simply going to start with chapter number 10. And we're going to try to understand what is this chapter, which is somehow related to our previous chapter. We're simply going to be talking about array lists. And before we do that, I got a couple of emails asking me about the homework. So before we start working on the new chapter, I am going to go to the homework to give you guys some sort of help about how to answer this question. Now, this question, I'll be honest, like I'm really, really impressed with it. I really like it. Okay. It's a little bit more complicated than anything we did before, but here's what you need to understand. The main function has been given to you. Okay. And in the main function, there's only one section here that I'm highlighting that you have to write your code in the main function. And this is a switch statement. Okay. And before that switch statement, you're simply going to ask the user to choose one of those options that you see here. We have on, we have in 1, in 2, out 1, and out 2. Of course, you have to go and read the whole question to understand what is the meaning of each one of them, which again, here's an explanation of what is that supposed to mean. But again, I'm just going through what is given to you. So you do have the main function given to you, and you are asked to complete this part. That's one of the requirements. And also, you have been giving the output of the main function. So that could be very, very helpful as well. Now, the main idea here, he wants you to create a Turkey class. And in the Turkey class, he is telling you all the details that you need to know about the Turkey class. All the static variables, all the non-static variables, all the methods, constructors, everything you need to know about this Turkey class. Now, the challenging part about this class is the measurement of timing. Okay, so you have to monitor the time that the turkey is going to be on. The idea is very simple. Let me just explain it. You're going to be asked to create 2 turkeys. Those turkeys, they could be stuffed or not stuffed. So you're going to be simply asking the user, as you can see here, where is it? Let's look at the output. He's giving you some text to explain how the game is going to run. And then he's asking you to enter the weight of the first turkey. And he's going to ask you if it's stuffed or not. And then he's going to ask you to enter the weight of the second turkey. And he's going to ask you if it's stuffed or not. Now, whether it's stuffed or not, that's simply going to affect on the time it takes to cook that turkey. So if it's a stuffed turkey, then it's going to take you 22 minutes. If it's not, it's going to be 18 minutes. Now, because this is a simulation software, we don't want to go with minutes. The equation that you're using here is simply going to measure time in seconds. He gave you an explanation about it here, but if you don't understand this explanation, he just said the question is asking you simply just to use this equation into measuring the current time. Now, the challenging part here, as I said, is to keep track on the time. Okay, that's a big deal. So what I would say here, at the moment you create the turkey, you need to know how long is it going to take for the turkey to be cooked. Now look at the variables that we have here. Oven on, so the oven goes on and off, okay? And this is a static variable, so it doesn't belong to the turkey itself. It belongs to the whole class. An instant variable, so this is not a static, the weight of the turkey. And this is, again, a non-static variable. It's a stuff that's a Boolean, so it could be true, it could be false. Now, a non-static variable in oven, so that goes on and off, depending if the turkey is on in the oven or not in the oven. And then you got the starting time. This is simply when you put the turkey in the oven. And then this is the cook time, what specify the total time that the turkey has been in the oven. So this is going to keep track on how long the turkey has been in the oven. And that's, again, if you just go ahead and read those and follow them line by line, try to construct and build a turkey class. And as I said, the idea here is that measuring and tracking the time that the turkey will be in the oven and knowing how long is it going to be. So he's giving you some explanation here into the oven, the method that will put the turkey in the oven and set the time to start time. So here it is. And then out of the oven, that's to remove the turkey from the oven and check how long the turkey has been, for how long the turkey is in term of being fully cooked. It displays a message indicating that the turkey need more cooking time. So, and let me just show you, there are three options, by the way, whenever you take the turkey out of the oven. So to get a better idea here, let's look at how the program is going to run. So the moment you decided what's going to be the situation for both turkeys, you're going to be hit with this message. Those output message. On simply means turn the oven on. In one, put the first turkey in the oven. In two, put the second turkey in the oven. Out one, remove the turkey, first turkey from the oven. Out two, remove the second turkey. Q, quit. So after you enter your choice, now if you enter a choice that doesn't exist in the list, invalid choice. Now, the first choice, you simply need to make sure that the oven is on. That's how simple it is. So for example, if you decided to put the turkey in the oven and the oven is not on, simply, again, the cooking will not start. So it makes sense, again, to turn it on first. And once it's turned on, this is one of the things that I'm not sure. How can you, oh yeah, if you decide to turn the turkey on again, once it was on, it's simply going to see a message that the oven is already on. You cannot turn it on again. Now, here's where we're going to stop. We're going to put the first turkey in the oven, and then we're going to get it out. Wait for a few seconds to get it out. Now, depending on, this is very, very important, depending on how long the turkey has been in the oven, and you compare that time to the cooking time, and you should tell me the percentage of how much that cookie was cooked. Okay. We have three options, I believe. One of them is undercooked, one of them is perfectly cooked, and the other one is overcooked. If the percentage that's going to be calculated was less than 59, that's not cooked, undercooked. 95, that's perfectly cooked. More than 150, I believe, that's overcooked and edible, I think. So here's what we do. We put the first turkey in the oven and we get it out. And then after that, we put it in again. Now here's what you need to understand. When you take the turkey out, the cooking time will stop. The moment you put it in, the cooking time will start again. So what I'm trying to say here, without trying to make it more complicated than it is, you focus on getting the whole thing done, measuring the time in the basic form. How long is it going to take? And then after that, the only challenge will be left is simply, how do you update the time every time you put the turkey in the oven? And when you get it out, how do you keep measuring that time and measuring the percentages so you would know when it's overcooked, undercooked, or perfectly cooked? And as I said, this is not very easy, but I will say most of the work has been given to you. So the only challenging part is, in my opinion, is the tracking of the time of cooking, which, again, I don't think it should be very complicated. It's just a matter of how do I keep track on the time using those methods. So here it is, into oven, out of oven. Those two methods simply should be utilized to keep track on the time that the turkey is cooked there. So I hope this explanation helped you a little bit. The first challenge again is to build the turkey class and then to complete this part. Now, this switch statement should not be very complicated. It's simply you ask the user for all these choices, and based on the user choices, the action should be taken. And again, logic here play a major role. For example, when you say N1, you cannot say N1 again because turkey is already in the oven. So all you have to do is to check if the turkey is in the oven or not. If it's not in the oven, you put it in the oven. If it's in the oven, show a message that says it's already in the oven. I will be looking forward to see your work on this because I believe this question is very, very good one. So now with that being said, we can move on to our next class. Now, of course, here's the deal. If you are working on it and you have question at any time, send me that question by an email. But most importantly, make sure you include your Java file with it. Make sure you include your work so I'll have a look at it so I can actually see your code and answer that accordingly. And if you guys need more time, I am willing to give you guys more time to answer this question. Okay. If we are all right with that, we can move on and talk about chapter 10 today. And chapter 10 is simply, we're going to start chapter 10 by looking at an issue that we didn't talk about. It's related to arrays. So let me stop sharing my screen here. And let me move to share my screen here. Let's see. Okay, and let's go ahead and create a new project. We'll call this one chapter 10. And finish. So we have chapter 10 here. Delete this file. Delete and sources. And we'll go classes. We'll call this one the drive class. Public static method, and so on. Let me go back here because I want to see something here about the participants. So we started this class with 8 students, and now I believe we are only 6 left or 5. I asked you guys a question at the beginning of the semester about if we can start the class early, and I got that some of you guys are busy and will not be able to make it. So I just want to ask the question again for the rest of us, if we can start the class, let's say 1 hour early. Would that work for you or not? Now, for those who are already here, if it's yes, please type yes. If one says no, then it's a no. We just continue at 6 p.m. So I see 2 yeses. Again, oh, we got a no, so forget about it. We'll continue at 6 p.m. And again, nothing changed. We'll just keep going. I just thought about giving that a try because I'm sitting at my home waiting for this class at around like from 4 o'clock, and that's why I've just thought about asking. But again, we'll just continue at 6, no problems. Okay, let's get back here. Today we are going to be talking about array lists. So what is an array list? And before I jump into what is an array list, let's go back and talk about arrays in general. So I want to create an array. And in this array, I want to store, let's say, names of customers that I have for my business. And I will just say array names, new, integer. And most importantly, I need to put a number here, which represents the size of my business. For example, I will say 10. Now the question that I'm going to ask here, what if the size of my array is simply something I cannot know. Like, I don't know. It could be 5, it could be 500, it could be 1,000, it could be 2. Sometimes in some applications, you really, really do not know the size of the array that you're dealing with, that you want to create. That simply will lead to a problem. Problem number 1 is, well, I can assume that my array size is going to be, let's say, 1,000 as the maximum number of elements that I can have. But what if you ended up having only 2 members in that class, in that array? Doesn't that simply means you reserved an array with a size of 1,000 and you ended up only using 2 elements out of that 1,000? So you're just simply wasting memory. And again, believe me, in programming, memory management is a big deal. So when you write a program, you need to put that under consideration, that how do I make my program consume as less as possible memory of the system? Because that's simply going to be reflect on how fast your system will be. Okay, so choosing a big number will imply that I'm losing a lot of data. And if I am, for example, let's go ahead and be realistic, and I'll just go ahead and put 10. But what if I ended up having 12 customers or 20 customers? That simply means the array that I generated right now, I will not have enough space to store the names of all my customers. So choosing a big number will lead to wasting some memories. Choosing a small number may lead for the whole program to not be able to serve the purpose of why it was created in the first place. So with that being said, we can say one fact about arrays. Arrays is your best choice when you know exactly how many elements you will have in your data, in your data structure, in your collection of data. That's where you simply go ahead. I want to create an array that will store the quizzes that I have for this class. I know how many quizzes I'm going to have exactly, so I'm going to go with that. But whenever you're dealing with a case of collection of data, that collection, you have no clue how big it could be and how small it could be, then arrays is not going to be your big friend. Here's one thing. Another thing, once the array size is specified, you will not be able to change it at all. So when I say array with a size of 10, then it's going to be 10 until the program is terminated. I can make it size, and I can come here and create an integer called size, and I simply can ask the user to assign a value to it. But even with that, once the user said the size is 10, then that's it. The integer, the size of the array will be 10, and you will not be able to change it after that. So if I want to say this here, what I just described here is the biggest flaws that arrays have, which is it's a fixed size. Once the size is fixed, it's chosen, then it's chosen. You will not be able to change it. And if you want to use arrays with a collection of data that you don't know what is the size of that collection of data, then that simply means you may end up wasting your memory, or you may end up having a program that will not be able to serve its own purpose. Now, with that being said, we have to ask ourselves, are there any solutions for this situation that we have here? And the answer will be yes, there are solutions. There's a solution called using what we call a linked list. And a linked list, it's a concept that you're going to learn when you take the class data structures. In this class, I don't know, we may talk about it later or not, but a linked list, it's a simple way that we can have a collection of data that's flexible with size. That doesn't have a fixed size. If you want to create a linked list with 10 values, then it's going to be 10 values. You want to extend the size to be 13, then it's going to be 13. You want to shrunk it to be 4, then it's going to be 4. So there's a flexibility in the size. But that flexibility comes with the price, which is complexity. It is complicated and it's slow. Complicated things in programming are usually slow. So a linked list, which again, we're not going to talk about technically what it is and how does it work. It's not what this chapter is all about. But a linked list, again, it's a technique that's available that will give you some flexibility when it comes to the size of the data structure, But that flexibility with measuring the memory and utilizing the memory to the best comes with a price of complexity, which simply means your program is going to be a little bit slower. Now, let's put the linked list on the side and let's talk about, do we have other options? And the answer for that will be yes. We have two options, actually, to solve the problem that arrays have. One of them is called Victor, and the other one's called array list. Now, Victors and array lists somehow are very similar, but they are different in a small details that you as a user may not be able to see them. Let's say not a heavy user, not a person who creates complicated programs that use multi-threading and those complex technical terms. But for someone who's writing a normal code, something very simple, very easy, an array list is your best choice. Okay, so what is an array list and what is a Victor? Both of them, again, are very, very similar. And I'm going to tell you what's the difference between them. And after that, we're just going to stick with the array list. And to be able to tell you that, let me just open Microsoft Word. And, I don't think I need to know. I need to create a Microsoft. Oh, yeah, let's do that. Let me just go ahead and share my Microsoft Word. Here we go. So here's my document here. And let's go ahead to drawing. Normally, when you create an array, let's say I'm going to create an array of 5 elements, 1, 2, 3, and 4, and 5. This is my array, 5 elements. That's how me creating a regular array. Now, with array lists, whenever you have an array and you want to add an element to the array, and the size of the array that you have right now, again, I'm just trying to explain. Let's just put the array list on the side. Let's just imagine the situation with an array right now. That I have an array with 5 elements, like the one that I'm highlighting right now. And then I found out that, oh, I need to add another element to it. Let's say 6. Here's the deal. Oh, let's just make the 6 elements. And then let's say I want to add a 7th element to it. Now we know by default, because I created an array of integers, and we'll call it AAR1, and we decided that it's a new integer of 6 elements, I cannot add a 7th element to that array. That's what we know by default. Here's how Victors and array list work differently. The moment you try to add an element to an array where there is no space, extra space for that new element that you're trying to add to the array, what's going to happen inside your computer? That's something that you don't see. A new array is going to be generated automatically. Okay, let's call it temp. And temp, it's an integer data type also, but it will hold, again, depending on if you're using an array list or Victors. If you're using a Victor, a new array with double the original size will be generated. So let's call this one temp1. And if you're using an array list, a new array will be created. And this one will have the value, which is the original size plus half of it. So if my original size was 6, it's simply going to be 6 plus 6 over 2, which is 3. So you will have 9. Now, what's going to happen after that? Once you have this array created for a Victor and this one for an array list, you're simply going to be copying those items one by one to the new array that you have here. So for this one, for example, you'll end up having 1 and 2 and 3 and 4 and 5 and 6. And let's say you want to add 7. And of course, the rest are simply going to be zeros. And let's see here, how many items do I have? 7, 8, 9, 10, 11, 12. So here we go. That's my new array. And for this one, you're simply going to have, again, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how array list works. So vectors and array lists, this is what they do. And again, all of that I'm talking about right now, it's happening behind the scene. You don't see it. You have an array. By the way, array list and vectors are built based on arrays. So with vectors, the moment you are passing the limit of the size of your vector, your original array inside that vector, you're simply going to create a new one with a double the size, and then after that, all the data will be copied from the original array to the new array, and then the new array simply will be called array 1 again. Because again, this one, it's just a reference. So instead of referencing this one, it's going to reference this one, and then the garbage collector will come and clean this area here. And the same thing will be simply applied to the array list. Is this part clear? Because I don't want to move on to the next part before I make sure that this part is clear. Okay. By not saying anything and not asking a question, I'm assuming that you guys have no issues.
I have a question.
Go ahead.
So, is there like an actual array list like thing, or is it just an array that you just keep adding to? Or
No,
like
it's an actually object called an array list.
Okay, so this is just replicating what it's doing.
Yeah, I'm just explaining what's going on behind the scene that you don't see.
Oh, okay, I understand.
So now you may ask, do you need to specify the size of the array list? No, you can. You have the option to do that. But I hope I'm reading the questions that I'm seeing from, by the way, the chat box here. The question was, do you need to specify the size of the array list? No, you don't have to specify it, but if you want to, you can. It's optional. And here's the thing. If you don't choose the size of the array list, there's a default value for it. And the default value, I'm not sure what it is, because if you just have to go to the documentation of the programming language and they will tell you what is the default size of it. I remember in C++, the default size was like 60 or something. But with Java, I'm not sure what is the default size. But the idea here, again, it's very simple. You have a normal array, and every time you need to add to that array, you're simply going to generate a new array, duplicate the size or the size plus half, and then you just copy the values from the original array to the new array. And then after that, reference the original array with the new one that they just generated. So the garbage collector will simply take this out. And everything that I said here, again, it's nothing that you have to do it by yourself. It's going to be done automatically. So that's, again, one problem. Now, you may ask a question. So if we have both of them, why do we need both of them? Why do both of them exist? Here's the deal. Originally, we had vectors. We didn't have array list. Array list is something has been added recently. And by recently, I'm talking about years. But originally, like I would say 10 years ago, maybe, or more, we didn't have array lists. It's something like I had to just go and do some little bit of research, historical research about it. Originally, we had vectors. And vectors are just simply how I explained them here. Vectors were designed, again, with one thing in their head when they created. They said, we want to create a data structure, an array that is multi-thread safe. Now, multi-thread safe, what is that supposed to mean? Again, when you're going to go and take a class called data structures, you will have a whole chapter that will explain to you what's multi-thread. But just to give you an idea, what is a multi-thread? Multi-thread is simply when you have a processor that contains, let's say, 4 cores, and every single core represents a processor by itself. So a single chip will contain 4 cores. Every single core has 2 threads. Simply means it can process 2 instructions at the same time. So a single processor can simply, again, this is the default that we have these days. A single processor will be able to process and execute 8 instructions at the same time. In another word, if I have an array with 8 elements, that simply means I can have access to all these elements at the same time. And that will simply make the processing much faster, because previously with a single core, you have to process them one after the other. But if I have multiple cores, I can process them all at the same time. Now, as simple as this may sound, but it comes with a lot of problems. The biggest problem is having access to all these elements at the same time creates a problem of independencies. What is that supposed to mean? Simply means, what if I'm having a sort of relationship between all the values in those locations and process them in that random format of accessing to them at the same time? May lead to some problems. What is that supposed to mean? Imagine that the second value in the array relies on the value of the first one, and the third one in the array relies on the value of the second one. So if I want to apply multi-threading in an application like this, that will lead to a lot of problems because I may end up processing this one before ending the process of the first one. And for that reason, having access to data structures like the one that I'm talking about here in a form of multi-threading may lead for the whole program to crash. So when they created vectors, they took that under consideration when they build vectors. So when it comes to having access to the elements of the vectors with multi-threading, this is where the process of multi-threading is simply going to be stopped. You're not allowed to process two before you're done with one. Even though technically you should be able to do that, but just because we know that this will lead to a problems, we will actually slow down the process and will not allow the multi-threading to get here. And that's where the safetiness coming from. So vectors were designed to take that under consideration. Array list, on the other hand, didn't take that under consideration. And because it didn't take that under consideration, array list is considered as not multi-thread safe data structure. Now, why do you care about that? At this point, we're not using any multi-threads here. So if you want to just put it as a general rule, if you're writing a program and you're taking advantage of the multi-cores and the multi-threads that you have in the processor, then you should not be using array lists. But if you are using multi-threading and multi-cores processors, then you should be using vectors. I hope this part is clear to everybody. So because here in this class, we're not at that point yet, we're not using multi-threads at all. So we are going to be focusing on array lists and how do we process array list and how do we create array list and how do we perform any of the operations that we can perform with array list. Now, if you go back to all the applications that we did before with arrays, at this point, you should start thinking about this like, oh yeah, now I can go back and replace every single array that I created before with an array list. And the answer will be yes, you can do that. But actually the question is, do you need to do that? So depending on the application itself, and let me just put it this way. If you have a very simple application that's not using multi-threads, and you don't know exactly what will be the size of the data structure that you're dealing with, could go up, could go down, you go with array lists. But if you know exactly the size of the array, then you go, size of the data structure, you go with arrays. Okay? Now, let me just stop sharing and let me move to the Eclipse to start demonstrating how do we use array lists. Now, before I continue, if you have any question at any time, again, I'm keeping my eye on the chat box, so I will answer any question that you may actually have. Okay, so how do we create array lists? Well, the number one, you have to import the class of the arrays. And now, array lists, by the way, it's a part of a class, or it's called collections.
I have a question actually.
Go ahead.
From the way we use array lists, will we ever actually like because you know how you said that it like splits the length of the list and then increases it, right? Basically.
Let me just increase the volume because I couldn't hear you clear.
So it creates a new list, but with 50% but 50% longer, right?
That's what it's going to done automatically.
Yeah. So will we ever see that? Like, because like
Nope.
that's because if we're adding one value,
you don't have to worry about that. It's just simply going to be done at the back. You will never get to a point that you have to worry about the size and how many elements do I have there.
Okay, thank you.
Unlike the arrays where you have to make sure that you never pass the limits or the boundary of that array list.
Yeah.
That array, sorry. Okay, so how do we create an array? As I said, you need to actually import it. Now, how do we import it? Again, very simple. If I come here and create an array list. Oh, and here's the deal. This is something very, very new to you. We use this simple here, less than and greater than, and you put the data type between them and you give it a name. So I'll say my list equal new array list. And then you also tell me what is the type, which is an integer. Okay, now he's complaining about something, which is should be insert complete. Let's see, syntax or insert a dimension to complete the reference type. Well, number one, he didn't complain. Oh, yeah. You have to put a parentheses after that. And he doesn't like the fact that we're using integers. I think I know the reason for that. Oops. My computer is adding characters. Let's go back here. Integer and integer. And of course, after that, I need to import array list. Okay, so it looks like we have a lot to talk about here. Number one, if you want to use array list, you have to import it. And here it is, Java util array list. Now, how do I create an array list? This is the syntax of it. Let's talk about this. Number one, that's the name of the class, array list, new, nothing new about that. But what is this? This part that I'm highlighting, the greater than, and sorry, less than and greater than. Array list, as I said, it's part of what we call a collection, data collection. And in programming, in general, we have something called generic programming. Generic programming, it's something that you should learn in the future in the data structure class specifically, or mostly, or maybe the next programming class that you will have. So what is generic programming? Generic programming is simply when you create something. I'll tell you something here. Imagine you want to create a class that will perform some operations on integers. Okay, so inside that class, you are simply going to go and say, well, let's say I'm going to have 5 integers in that class. I'm going to create them, integer x1, x2, x3, and xor, and so on. And then you're going to perform some operations on those 5 integers. Now imagine you want to create another class that will get the same job done, only using doubles, for example. So what are you going to do? You're simply going to copy the same exact class, and you may need to change the name for it. And then after that, all you're going to do is simply changing the data types to be doubles instead of integers. Now, when you put those two classes next to each other, you would notice that they are exactly the same when it comes to the process that's going to be performed, with one exception that the data that's processing is different. Here we're using doubles, and here we're using integers. And also you will notice that the name is different, of course, so you can call each class by itself. So this is considered duplication. Having one piece of code to get the job done and having exactly the same piece of code to get the same exact job done with only the difference between these data types raise the question, well, can I have something generic, something that will work on any data type? And that's where the term generic programming is coming from. Now, in generic programming, and again, this is not part of this class, but I'm just giving you an idea. You create a whole class with the new data type. It's called door. You call it whatever you want. So I'm going to create a class. And my data type that I'm going to be processed, I'm going to call it X. Now, X could be an integer, could be a double, could be a car, could be a box, could be anything. But I'm going to create the whole class to process X and X as a data type. Now remember, X here is not the variable, X is the data type. And then as I'm calling that class and creating objects out of the class, I'm going to specify what is the data type. So every single X in that class is going to be replaced by that integer or by that double or by that whatever data type that you're trying to use there. So
Are you saying that you're making an array of objects? Or an array of
exact.
attributes with objects?
It's an object. You cannot use primitive data types with array lists.
Okay.
And because of that, when you type, let me just show you here. When you type integer, and you type integer here, it's giving you an error. You can use primitive data types here. It has to be a reference. And that's one of the reasons why we actually have a class called integer and a double with the uppercase D. But again, at this point, if you understand, you're not, again, I don't want to give you a headache by trying to understand what is generic programming. That's a whole different chapter to talk about. But what I'm saying here is that this here is considered generic programming. And what is that supposed to mean? It simply means there is a class called array list, and inside the array list, the data type that array list is processing is simply something that could be anything. Could be an integer, could be a double, could be a car, could be anything. Is that clear? Let me just give you another idea.
Yeah,
You see
yeah,
here, let me just put here array list 1, and let me create another one. Array list 2, and this is going to be, this is going to be strings. And we know string is not a primitive data type. Well, my keyboard is 2, and this is string. And that's acceptable. Of course, I need to put a space here. And let's create another array list. Let me put this here. Control V. Array list 3. This time double with an uppercase D. That's very, very important. And you know what? Let me just go back to the the book project. Even though I have an error here in the main class, but here's what I can do. Array list, book. You see where I'm going with this? So let me close this, save it, yes. Save it, yes, and here we go. So you can create any array list with any data type as long as that data type is actually a reference. It's not a primitive data type. Is that part clear? Okay, let me just make sure I am following the instructions. I don't want to jump ahead. Okay, so here we go. This is an array list. I created 3 different types of array list, and let's focus on the one with the strings. And let's call it names. Name list. Okay, now the question is,
string or double?
Huh? Oh, double. Okay, sorry. Let's just change that to string. And let's change that to string as well. Now, the question that we have to ask ourselves, now we know that instead of using an array of strings, I can create an array list. And we know that I really do not need to specify the size, and I can add any amount of elements that I want to have. So the question is, how do we, and by the way, I teach C++ as well, and this is something that I just remembered from C++. In C++, we don't have array lists, we only have vectors. And the vectors could be created using those technique. And we also have another technique that you can assign an array to a vector, and then the vector the array is going to be converted to vector automatically. So instead of going with new array list, you just start with a curly brace and just list the values that you have. That's in C++, by the way. But in Java, I'm not sure if we have that feature or not. Let me just give this a try. I'll just say AAA. I'll say BBB. Put semicolon, comma here. Nope, he doesn't take it. I knew it. That's not going to be the case. You cannot do that. So let's go back and let me take this away. Oh my God, my computer is really acting up. My keyboard needs to be charged. I'm bad. I'm so sorry. It's running. The battery is low. That's why it's acting up. So here we go. Name list equal new array. Now let's go ahead here. Let's talk about how do we add items to the array list. Now, one thing you should know, array list comes with a long list of methods. And to be able to utilize array list to the max, you need to have an idea about those methods. And the PowerPoint simply takes you through the whole process. What I'm going to do, I'm going to post maybe a table later about all the methods that are associated with array list, and you can have them with you anytime you want to use it. So how do we actually add an item to a list, an array list? And the answer will be very simple. Name list, which is my name of the array list, dot add. So I call it, and then what are you going to add? I'll put, for example, Adam. And let's just add another item. Control C. Let's say we want to add John. And then let's add a third item. Now, in the third item, I'm going to put, let's say, Mike. Now, the order, how you add those items to the list is simply the same order that they're going to be stored inside that list. So Adam will be the first one, John will be the second one, Mike is going to be the third one. Now, what if I want to have a little bit of control over where exactly I want to put my item? And this is something, again, a little bit different than arrays. You have to tell me, where do you want to put it? For example, I want to put it at index 1. So here's what's going to happen. Let me change this one to be, let's say, Smith. Now look what's going to happen. Since I specified where I want to add Smith, it's simply going to be added at index 1. So if you, again, Adam is index 0, so John is index 1. Putting 1 here doesn't simply mean that Smith is going to replace John. It simply means Mike and John are going to be shifted one step to the right or down, and then Smith will take the place. So my final array list is going to be Adam, Smith, John, and Mike. Now, the question is, what if I want to have access to those items? Well, we can use a for loop. For integer I equals 0. I is list then. Let's look at this. Name list dot length. Let's see here. What is he complaining about here? Name list, no. We do have a method that will tell me the size of the array list. Yeah, he doesn't like the length. Let's see here. Let me just look here to make sure that I got the name of that. Size is empty. No. Size, yeah. Size, my bad. Not length, dot size. Size will tell you how many items you have here. So if I come here and say system dot out dot print line or print, and I will just say, look at this, name list dot get. And you have to tell me the index that you're trying to get. In this case, we're trying to get I. And let's give this a try and run it. And here we go. Adam, Smith, John, and Mike. Now, I just want you to imagine here and think about this, comparing that to array. You don't have to deal with sizes. You don't really care what will be the size of this. You can add as much as you want, and you can remove as much as you want, by the way, as well. So this, again, this example here is just summarize why array list is important. Because, again, you can create a collection of data without worrying about memory management. If you want to add more, you can add more. No matter how much data you want to add, the size of it is going to be keep adding up and adding up. And the way, again, array list works comparing to what they call it, the vector. Again, remember here, let's say the size of your data is 100 and you want to add, and that was the max of number of elements you can add to it. And then after that, you have to add another element, but the vector is already full. So what's going to happen is going to double. So it's going to be 200 to add one. But with array list, they said there's no need to double the size. Just take with the original size and add 50% to it, which again, that makes, I would say, a little bit better management for the memory. And that's, again, how array list is a little bit better than vectors. Also, because of the thread safe of the array list, it's a little bit faster than vectors, but it would not be faster than arrays. Array lists are going to be slower than arrays because of the fact of every time you give the array list to be full, a new array is going to be generated. The data is going to be moved from the original one to the new one, which again, that takes time, which is going to be added to the processing time, which is going to make it a little bit more complicated. Okay, so what else we can do? Let's think about this. What if I came here and say, let's create a new array list. Okay. Control V. And this time I'm going to call this one names. And instead of creating a new, I'll just say equal name list. Now this, whatever I did here, is simply whatever was applied to the arrays is simply applied here. So what's going on here? Names and name list are simply two array lists references. Array lists are referencing the same spot inside the memory. That's simply what's going on when you do it this way. But the question is, what if you actually want, instead of having it this way, you want to actually have a copy of this one? So we have a method called clone. Let's see here. Clone method is used to return a shell copy. We'll just leave that, but let's just focus on the fact that if you do it this way, you're simply checking, you're making those two array lists referencing the same spot inside the memory. So the most important two methods are simply get and add. We do have, again, a long list of methods. One of them, for example, if I come here and say system.out.print line, and let's go ahead and type name list dot index off, and let's just put, for example, Mike. And if I run it, Mike is located at 0, 1, 2, 3, actually, because in the list here, Mike is the last one. So it should be 3. Let's see if I run it. And here it is, 3. Now, what if the element that I'm looking for doesn't exist? It's going to tell you -1 as an indication that that item do not exist in that array list. So when you call for an index and that item that you're calling for, it doesn't exist, it's simply going to give you a -1. I can check if it's empty. So let me copy this. And I'll check it before and after so you can see if you have an item there or not. So we'll just come here and say empty. Is empty, sorry. Now, it should be true here. And here it should be false. So let's run it. And you'll see it's true here. And now it's false. You can check again for an array if it's empty or not. You can clear it. Let's see if I can clear it here. If I come here and say clear, oh, wait a minute. Why is he complaining? Print line. Oh, what is he complaining about? Oh, wait a minute. No. Yeah. When you clear it, you don't have to print it. Just clear it. That will, again, if you clear this empty should be true after that. Let's go ahead and give it a try. And now it's true. So there's, again, as I said, a long list of methods that we can utilize and use to have access to those. So we've got clear. We can check if an item does exist or not. So, for example, instead of just asking for the index of an item, we can just check. Say, and I'll say contain. So contains, that should be true. And here it is. It is true. It contains it. Now let's just put S here and run it again. And that will make it false. Okay. So let me just, I'm looking at the list of methods that I'm trying to see which one of them is used a lot. Let me have a look. Oh, yeah, very, very important. Remove an item. So let's go ahead and remove an item from here. And then after that, we're going to have to print it. So if I say, again, name list dot remove. Okay, now you have to remove something, and you can remove an item using out of two techniques. You can remove it by telling me the location of that item. So for example, remove 0 simply means remove atom. So if I go ahead and remove atom from that list, and let me print it again, you would notice that I will get the list printed again, but this time, see, where is it here? Those are the 4 items, and now I got 3. Atom was removed. I can also remove them by the object itself. For example, I want to remove Smith. Now, if I run it again, you would notice that Smith is going to be gone and Atom will be kept. And here it is. So that's how you remove. Just like how we added an item here when we said add a Smith. So at index 1, that simply led to John and Mike to be shifted. When you remove an item from the list, that will lead to a spot that's going to be open, and all the other items simply are going to be shifted to cover that spot. So when I removed Smith from this list, which was the second value, the third and the fourth value simply were shifted one step to the left to cover that space that was left. Now, one of the things that when we talk about methods and programming in general, we like to describe the complexity of that method. Okay. And this is something you're going to be dealing with in the future, but you don't have to worry about it right now. But it's a good idea to have an idea about it right now. Let's talk about add an item. When you add an item to an array list without specifying the space where you want to add it, it's simply going to be added to the end of the array list, right? That's something we talked about here. Now, the question that you have to ask yourself, how complicated that process is? And the answer will be, it depends. If there is a spot to add the item with no problems, then it's just going to be added. But what if you're trying to add an item to a list that is already full? We said if that's the case, you are going to have to create a new array with the new size and copy the values from one array to the new one and then referencing the new array with the old reference value. That, again, it's another level of complexity. So here's the deal. When you describe any method to anyone, you are not allowed to take the best case scenario. You always have to talk about the worst case scenario. It's okay to mention the best case scenario, like you have a spot and you can insert it with no problems. But what's most important is to explain and do analysis for the worst case scenario. And a worst case scenario, when you add an item, is simply when you have your array full and you have to actually create a new one with the extra size one and then copying the data from one array to the other one. That process takes time, which adds a little bit more complexity to the process. Now, what about removing an item? Removing the items, again, depends on where are you removing from. So if you're removing the last item in your array list, then you simply have no problems. Because it's the last item, it's simply going to be removed. But if you're removing the first item, that simply means all the data need to be shifted. And shifting, again, it's a little bit complicated. And that, again, is considered the worst case scenario. So removing item, best case scenario, you're removing the last item. Worst case scenario, you're removing the first item, because removing the first item simply implies that all the data need to be shifted, and that will make the process a little bit more complicated. We have another method called remove all, and remove all simply very have the same. You can actually, with remove all, you can tell me what are the elements that you're trying to remove. So you're gonna have to have a list of elements that you're trying to remove from your original list to be able to remove. You can change, by the way, a value in your array. Let me show you what do I mean by that. So here we removed Smith, and because we removed Smith, we ended up with Adam and John and Mike. Let's say we want to change John to Jonathan. So here's what I'm going to do. I'm going to say my list. Sorry, it was name list. Dot set. And what we're trying to set, we're trying to set John, which is the first item. And we said, I don't know if I'm pronouncing it correct. No. Jonathan. Let me hope that this is the right spelling for the name Jonathan. Let me copy that, putting it down, and let me run it. And now you'll see the list printed. John is replaced with Jonathan. That's another method that's available. Size will give me how many items do I have there. We can convert, by the way, an array list to an array just in case you need that. So I can come here and say integer, and I will say my array equal name list dot to array. Let's see, why is he complaining about this? Change the type object. Oh, wait a minute, sorry, yeah. I forgot, why did I go, it's a string. Should be a string, right? Yeah. Add the cast of string. Okay. I'm not sure why is he acting that way. I need to double check on that. But I should be able. Oh, wait a minute, my bad. Not that way. I just realized. Let me take this away. So this is going to convert it to an array. And the toArray method in the document says it's also used to return an array contains all the elements in the list in the correct order, same as this method used to return an array contains all the elements. Yeah. So what is he complaining about? If I come here and say it's a string, let's go Control Z. this casting part that I'm not sure why is it acting that way. Why do I have to cast it? It's an okay, I'll just put it for now. I'll try to figure this out later. I'll put question mark here. We can reduce the size of the array list if we want. And by the way, array list has two items to describe size related properties. One of them is size, which simply tells you how many items do you have, and capacity. Capacity is going to tell you the total available spaces that you have in that array. The moment the size equal the capacity, that simply means you use the whole available space for you, and you simply can't, you're going to have to go ahead and increase the size if that's the case. Let's say you have been adding items to an array list, and then after that you decided to start removing items. And as you're removing those items, all the values are shifted to the left, and then you'll end up having the capacity to be very, very big. Okay, and you're not utilizing the whole capacity. You simply at that point can chop it and get rid of all that extra space that was reserved for the array, and only keep the one that you have data in. Let me just show you what do I mean by that. Let me share my screen here. Imagine you have an array list, and you have been adding spaces, increasing the size of that array list. Let's say 8, 9, 8, 9, 8, 9, 8, 9. So you've been doing this for a really long time. And then after that, you start removing items. And as you remove the items, let's say you removed all these items, all the other items were shifted. But what happened to the spaces that you have here? They're not holding the value of 0. That's not the case, but this space is simply still reserved for your array list. So the method trim to size will simply take all this space away and just utilize the space that you have here. So what's going to happen in reality, a new array list is going to be generated with the size that you see here that's required, the size. And the item is going to be simply sent to that one, and the old one is simply going to be removed. That's how we can get rid of that extra space if we actually need to do that. This is, again, a tool or a feature that you have that will help you manage the memory in a better way. I'm going to stop at this point, so let me stop sharing. Next class, we're going to continue with methods. I'm going to bring some examples of how do we utilize arrays in real life examples. And we're going to continue with those methods and see if we actually have more methods to talk about. And if you have any questions, let me know. Let me stop recording so this file will not go very long.